Hello young innovators and the honorable juries. I am Ataya, Azaria, Robby, and my partner
Emiru, Misbahul from MTSN Wangmalan City. In this video, we are going to tell you about our research in Indonesian Science Project Olympiad 2024. Assalamualaikum warahmatullahi wabarakatuh.
Apple is one of the commodities that are highly needed by Indonesian society. Apple production in Indonesia reached 523,000 tons per year, and 26% of those are processed into apple jam.
However, the moisture content in apple jam from local factories still exists as an high standard at 36.96% to 42.62%. This is because addition of pectin during apple jam production.
This problem can cause massive growth of microorganisms, making the jam easily fermented and spoilage. In response, many research have invented innovation to reduce the moisture content of apple jam.
However, these innovations are relatively expensive, damaging nutrition, texture, and not environmentally friendly.
Based on this problem, we have made an innovation entitled Design of Moisture Content Reduction Machine based on non-thermal electroosmosis dewatering to improve the quality of industrial food-grade apple jam product.
The honorable juries, the objective in this research consists of: first, to explain the working principle and mechanism of our innovation for reduced moisture content in local apple jam commodities.
Second, to determine the technical feasibility of our innovation. And finally, to explain the potential and advantage of our innovation compared to previous technologies.
In this study, we use this method based on Rosmiati 2019. This method consists of systematic arrangement and simpler application. We conducted this research at the researcher's home and the science laboratory of MTSN Wangmalan City from November 2023 until February 2024.
The first stage is analysis. We analyze the moisture content of apple jam from local industries, the electroosmosis principle to reduce the moisture content, and the weaknesses from the previous innovations.
In design stage, we make the innovation working principle, electrical system design, and physical design using SketchUp.
In the development stage, we made our innovation work automatically by using a digital timer switch and utilizing food-grade stainless steel wire mesh as electrodes, so that it's safe to be in direct contact with food.
In the implementation stage, we carried out some tests referring to several previous studies to determine the effectiveness of the technology that we made.
Finally, the last stage is evaluation. We evaluate our innovation system as a whole, benchmarking the effectiveness, price, usability, and performance of the device compared to other innovations. There are the tools and materials we use.
And these are the results of our research. This is a working principle of our innovation. In order to reduce the moisture content of apple jam, we utilize 12-volt 3A adapter and the DC electrical energy source for the device. Then, when the digital timer switch turns on, the electricity will flow from the anode to the cathode. These two actuators will produce the electroosmosis process. This device will automatically stop when the timer on the control unit has finished.
The use of non-thermal process and food-grade stainless steel electrode with low corrosion, high heat resistance, and don't damage the nutritional content of apple jam.
According to Dalibi 2016, the non-thermal process works without using heat, so it doesn't cause chemical change for food.
On the other hand, based on the voltage input and power test results, the voltage variation of 48 volts emits a power of 145.7 watt with an electric current of 3 amperes. We also found that the 48-volt variation with a treatment time of 180 minutes was able to reduce the moisture content from 70.31% to 33.9%.
According to Prasetyo 2019, the longer time and the higher voltage applied during the electroosmosis process, the higher amount of moisture content that can be reduced.
To show the power of the reduction in moisture content, we calculate the energy of dewatering. Based on the result, the base variation is also 48 volt with 180 minutes. It was able to produce a dewatering energy of 429.39 gmol. Based on Al-Ashai et al. 2008, the higher electrical power and reduction of moisture content, the higher energy of dewatering can be produced.
Based on carbon footprint calculation, this innovation can support net zero emissions, because it only produces a carbon footprint of 0.3 kg carbon dioxide to 0.5 kg carbon dioxide, which is lower than the average emission from using electronic device of 0.8 kg carbon dioxide.
The overall use of power in the device only requires 146.1 watt-hours with an estimated daily electricity use of 3.5 kilowatt-hour and only needs about 5,000 rupiah for each device.
Compared to the previous 9 innovations, our device is more outstanding because we designed to make it work automatically.
This device is also environmentally friendly and food grade with a manufacturing cost per device of only 1,160,000 rupiah. This is relatively affordable for the food industry in Indonesia.
Based on this result and analysis, several conclusions. First, this innovation is able to reducing moisture content without damaging the nutrition of apple jam, because it's non-thermal method.
The variation 48V with 180 minutes has the best moisture content reduction. This variation can decrease the moisture content of apple jam from 70.31% to 33.9%, with overall power consumption of the device was 146.1 watt-hour.
And finally, this innovation is more durable, easy to clean, work automatically, affordable, and environmentally friendly compared to previous innovation.
To protect our research work, we have obtained a copyright from the Director General of Intellectual Property, Ministry of Law and Human Rights of the Republic Indonesia.
And here is the documentation of our research.
Thank you for your attention. See you in our next project. Wassalamualaikum warahmatullahi wabarakatuh.